Right, so hello everybody. We've got a few people here already, so a couple of people made it early. Fantastic. I tried to sort out the technology here. It's all falling apart. God, this lockdown is crazy. So, hello everybody. Can you hear me? Hi. Oh, brilliant. Hello, fantastic. That's excellent. So we get a few people in here. Brilliant. How is everybody feeling today? All good? Excited? I just need to quickly check something here. Yep, that works. Good. All good. All is working. So we've got a few more minutes for people to join. And then we do a little bit of revision for logarithms. I told you that my housemates are going to join us. If I can motivate them. I think they are asleep at the moment. It's disgraceful. But at least I can trust the students that they are awake. Well, most of them. What on earth is going on here? That's weird. Oh well. Very strange things. Hello everybody, great. Oh, we even get some second years here. Brilliant. Wonderful to see that. And in Spanish as well. Wonderful. A truly international affair. Affair? Is that the right word? God, I'm talking rubbish here. But I think the second years are used to that. Aren't they, Richard? You guys know me. I'm talking nonsense most of the time. Right. Good. So I think we soon make a start. It's very kind of you to say that, Richard. A lot of people are asking in various group chats when they will receive the timetables. I know it's really annoying that you haven't got your timetable as of yet, but I hope that you will get them hopefully the end of next week. And I say that because we have been really working quite hard to sort out all the timetabling issues and all these things. When can we schedule lectures, seminars, practicals, etc., etc. And getting that sorted for the whole university is a Herculean effort. So only beginning of this week, I think, I got a request to review my timetable, and I have to respond by, when is it? By tomorrow, and basically approve what the suggestions are for the timetable. Then they usually use or have to take another week or so to finalize it. So I hope by the 18th or by the 19th you will have your timetable, but I don't want to promise anything, so please don't hold me to it. But as I said, it's not a trivial task. Okay, so let's have a look at some stuff that people might feel a little bit worried about. And we've done a session on logarithms, I think 2 weeks ago or something like that. And what I thought might be quite a useful idea is to revise again and put a little bit of practice to it. So I thought, let's do a few calculations. And one of the calculations that I want to do with you is related to an article that I read quite recently. And that also involves two of my housemates, this article. So here are my two housemates. This one here is Coco. And this one here is Lady. And the article actually is talking about find the age of how old is your dog? And people say, well, one dog year is how many years of a human? How does that relate? Does anyone know one dog year related to human years? 7. 7. 7. Okay, around 7. That's interesting. Because actually, turns out that this is pretty much a myth. So 7 is not true. And I will post on the group chats then later the article basically. What the scientists have done is they looked at the methylation pattern of the DNA, and for the first years we will do that in the BI300 sessions. And they found that the methylation pattern is an indication for age. So the more methylated your DNA is, the older you are, basically. And they could also correlate the methylation pattern of dogs, and especially with Labrador and Retrievers, and I think both of them are sort of in that category. With Coco, we know he is a purebred Labrador. With Lady, she's a rescue. We don't have an idea what kind of breed she is, but we think there's a Labrador in it, amongst other things. And the scientists actually found that the aging of the dogs is not linear. And they found that you can convert actually human years, so let's write that as human years, into dog years with the equation 31 plus 16 times the natural logarithm of the dog year. And that seems to be this correlation equation. So it's not 7. It is this equation. So what does that mean? Let's, for example, say we know that Lady is about 2.5 years old. 2.5 years old. Because she's a rescue, we don't know. So let's quickly do the calculation. How old Lady would be in terms of human years according to her DNA methylation pattern. So that's not terribly difficult. Human years equals 31 plus 16 times the natural logarithm of 2.5. So let's see if we can do that. I need to get my calculator out. So here we have 31 plus 16 times ln of 2.5 years. And that gives us an age of 45 2/3. So, lady is the equivalent of a 45.67 years old. Now, if you've done that with the equation for 7, so 7 times 2.5 would give something 17.5. According to the 7 times, lady would still be a teenager. According to the methylation pattern, lady is a middle-aged woman. Let's put it this way. Although I'm not entirely sure in terms of her behavior, but you know. Okay, let's do it the other way around. Let's say, how old is a dog? So we are looking for the dog years. If they were equivalent to, let's say, 60 years old human. How old would they be? So, we take our equation. Human years equals 31 plus 16 times ln dog years. And what we are looking for is the dog years here. So here we've got 60 equals 31 plus 16 times ln dog years. So the first thing that we do is we want to have everything with the logarithm on one side, everything without the logarithm on the other side. And it doesn't matter which side we are dealing with. So let's bring everything without the logarithm onto one side. So we bring the 31 to this side. We subtract both sides by 31. So we get 60 minus 31 on one side equals 31 minus 31 plus 16 ln dog years. So here the 31 and 31 cancel out. And on the right hand side we have 16 minus 31, and I think that is 29. 29 equals 16 times ln dog years. So we also need to get rid of the 16 here. So we divide both sides of the equation by 16. So we have 29 over 16 equals 16 over 16 times ln dog years. And this one cancels out, so we don't have to worry about it. So we have 29 over 16 is equal to ln dog years. So how do I get rid of the ln on the right hand side? What do I have to do in order to eliminate, to cancel out the ln? Any ideas? Any suggestions? Absolutely right. So people make the suggestion of taking both sides to the power of e. And I'm delighted that Alessandro says that, because last week or the week before, I remember, I think it was Alessandro and Bernardo who had the issues with the fingers. Is that right? No, or it doesn't matter. So we do that. We take both sides e. So on the left hand side we have e to the power of 29 over 16 equals e to the power of ln dog years. Yeah, Bernardo said yes, the fingers were very tangled. But I'm glad that you sorted that out. So, on the right hand side, e and ln cancel each other out, like we've just done with the 31 and the 16. So, we have now e to the power of 29 over 16 on the left hand side equals, well, what's left? We've got the dog years. Let's go to the calculator and try to do the calculation. So we have e, and on my calculator this shows as exp, and I think in Excel it's also exp with a bracket. So 29 divided by 16, bracket closed. So this would be 6.1 years. So let's put that down. So the dog years is 6.1 years. So if the parent of a dog is 60, then the dog, if they were the same age, would be 6 years old. So I thought that's quite an interesting calculation. Hey, let's do another log calculation, just to get familiar with these things. Let's say, what can we do? ln, I'm just making something up here. ln 4x minus 5 equals 0. Hey, why not? And I want to find x. So how can we do that? Again, we want to get rid of the ln, so I will follow. I give you a couple of minutes, try to figure out what is x in this case. And then we do it together. Give you a few minutes, post it, what is x in this case? .5, 3.5. Interesting. Anyone else? Hazard a guess? 1.25. 1.5, 5 over 4, 1.5. I'm just reading aloud the comments. Okay, let's do it together. Let's see how we can do that. So, we want to get rid of the ln. And as people suggested earlier, what we need to do, if we have ln, we just take both sides e. So, on the right hand side we've got e to the power of ln 4x minus 5 equals e to the power of 0. What have we got on the left hand side? We've got e and ln, and we know that this cancels out, so all we have left is 4x minus 5 equals, what is e to the power of 0? Actually, what is any power, any number to the power of 0? It's always 1, absolutely right. So all we have left is really an equation where we have 4x minus 5 equals 1. Now we bring the negative 5 to the other side by adding plus 5 to both sides. So we've got 4x minus 5 plus 5 equals 1 plus 5. So the 5 eliminate. And on the right hand side we've got 6. So we've got 4x equals 6. And we divide both sides by 4. Then we have x equals 6 over 4, which is the same as 3 over 2, which is the same as 1.5. Simples, as my friend Alexander Orlov would say. God, I am totally obsessed with adverts. Please don't tell my wife. That makes sense? This is how we are going to deal with logarithms. Right, now let's have a look at something. Oh yes, let's have a look at something with, instead of natural logarithm, with logarithm to the base of 10. So let's say we have negative logarithm to the base of 10 of an unknown x equals 7.2. Let's do it like that. And now we need to find what is this x. So the best way of dealing with that is, let's get rid of this negative sign here. We just multiply both sides by negative 1. Then we have minus log 10 of x times minus 1 equals, well, 7.2 times minus 1 gives negative 7.2. And minus times minus is a plus. So I basically brought the minus to that side. So we've got log 10 of x gives us negative 7.2. How do we get rid of the log 10? Question for you guys. How do we get rid of log 10? Right. So because we have to the base 10, we need to take everything 10 to the power of. And I write it like that. When we were dealing with the ln earlier, ln was to the base of e. And that's why we took everything e to the power of. Now we've got log 10, and therefore we have to take everything 10 to the power of in order to eliminate it. So we have 10 to the power of log 10x equals 10 to the power of minus 7.2. And 10 and the log 10 eliminate, so we have x equals 10 to the power of negative 7.2. What does negative 10 to the negative of something actually mean? Well, we can see that as this negative sign is sort of the leftover, the remnant of a fraction line. Because we can write this also as 1 over 10 to the power of 7.2. That's exactly the same in terms of writing. These two things are exactly the same things. But convention is that we won't leave it like that, because when we report a result, we will always have it as an integer number, as a whole number up here. So what we need to do in this case is we just need to convert that, or probably better this one, with our calculator. So what we can do is 10 to the power of negative 7.2, and that gives us 6.3 times 10 to the minus 8, and that the usually calculators can't do a 10 too, so they put in this capital E. So if you see a capital E on your calculator, it means 10 to the power of. So we have 6x equals 6.3 times 10 to the power of negative 8. And this is something that we will do quite frequently when we are dealing, for example, with pH in the BI308 module. So this is an equation that we will encounter quite often, actually. Is it always log 10? No, you can actually do it, you can use whatever log you want, but the most common ones really are log 10 or the log E, which of course is usually written as natural logarithm. These are the two most common logs that you will encounter. If you are in computer science, they very often work with log 2. But we are not dealing with that, and I'm deliberately not showing you how we can convert one logarithm into another different bases. This is getting too confusing. If we are just simply using log 10 and log E, or the natural logarithm, then I think that's absolutely fine. Are you happy with that? Make sense? Good, fantastic. Right, let's do another one where we can do something with the logs, with log 10. Oh yeah, here's a good one. Here is a good one. So let's say we have something A, whatever A is. A equals B minus log to the basis of 10 x over c. It's a very common equation, and we will discuss this equation quite a bit in the skills module. Richard, do you recognize this equation? If he's still around? A bit rusty. Yeah, this equation is a bit rusty. Okay, I'm not telling you where this equation comes from because let's have a little bit of surprise for the module. I want to know what is x. How do I find x? Well, again, all I need to do is really pack everything with the log to one side and everything without the log to the other side. So, first of all, let's move the log to that side. And we add both sides plus log x over c. Then we have on the right hand side a plus log x over c. And I'm too lazy to write the 10 down because we know that it's base 10 equals b minus log x over c plus log x over c. What we see here, this term and this term cancels out. We bring the a to the other side with a negative, so we've got log x over c equals b minus a. Okay? This time I write the 10 down here. So we have log all on one side and everything that's not log on the right hand side. So what we can do now is get rid of the log, and again we do the 10 to the power of, because that's our base here. So we've got 10 to the power of log 10 x over c equals 10 to the power of b minus a. 10 and log cancel out. And on the left hand side we've got x over c equals 10 to the power of b minus a. We want x, so all we need to do is we multiply both sides by c. So we have cx over c equals 10 to the power of b minus a, again divided by c. The c cancels out, and we are left with x equals 10 over b minus a divided by c. And again, simples. So watch out for this equation here, because we are going to deal with that quite extensively. And my instinct tells me that you will write probably an exam about that. Yes, you will write an exam or a test. You are absolutely right. I made a mistake. Yes, you are absolutely right. Thank you. Serves me right. Thank you. You multiply by c. Why did I put divided? C. Let me write this nicely. God, I'm probably in caffeine starvation mode. C times 10 to the b minus a. Thank you ever so much, Ella. At least one of you is asleep, is awake. I'm not. Thank you. Right. Shall I risk another one? What do you think, guys? Shall I do another one? Okay, I risk one more. Let's make a complete ass of myself. Last week, a lot of people told me that they are quite scared of one equation that has an ln in it. Those of you who did chemistry. Can you remember an equation where there is an ln in it? And that you absolutely hated when you did chemistry? And a lot of people said, oh, I simply didn't get that. No? Yeah. The Arrhenius equation. Who is scared of it? Who hates it? Or no feelings about? Yeah, me, yeah. Oh, I didn't expect it to have such a, Let's not go into detail what it says. Let's just mess around with it. Okay? So the Arrhenius equation is just a little bit of symbols here, and we are not working with these symbols at the moment. What they mean, we will discuss them again in the BI 308 module, the skills for bioscientists, when we discuss kinetics. But basically what it says, the Arrhenius equation, it says K equals A times E to the power of minus, say, X over RT. Whatever these symbols are. And I'm not going into detail what they are, what they actually mean. We just want to rearrange that so that we can find X. So X is what in terms of these symbols. So what can we do with this? And what we can do is we can put everything with E on one side and everything that is not E on the other side. So here we need to bring the A to the other side. And we get this, and I make sure that I get it right, we divide by A, both sides. So we've got K over A equals A over A, E to the power of minus X RT, whatever this is. I hope I've done it right, yeah? Good. This cancels out. So we've got K over A equals E to the minus X RT. What can I do in order to get rid of E? How do I eliminate E? You guys absolutely rock. You totally got it. So I take both sides ln A. ln. So we've got ln k over a equals ln of e minus x over rt. Ln and e cancels out. So I have ln k over a equals minus x over rt. And what I can do now is I multiply both sides with RT. Then I've got RT ln k over a equals minus x. And I bring the negative to that side, and I've got minus RT ln k over a equals x, or x equals negative RT ln k over a. That was pretty straightforward. There was nothing to worry about, was it? It's not that bad. Now I can, of course, write this in a slightly different format. I don't like this minus here. So what can I do with that? What I can do with the minus, I can put that into the ln. So minus ln k over a, I can write this also as ln a over k. So the minus goes in here, and what happens is here k and a changes place. We can quickly do why this is the case. I showed you last week that if we've got ln, say, k over a, we can write this as ln k minus ln a. You remember? We also said that if we've got ln k times a, for example, this would be ln k plus ln a. Remember vaguely? Yeah. So, what happens if we've got minus ln k over a? Well, we said we have got minus ln k minus ln a. So all we need to do is we need to multiply this minus sign into here. So we've got minus ln k, minus times minus gives plus, plus ln a. And I can write this as ln a minus ln k. And that I can put together as ln A over K. K over A. That was just a bit of messing around, just to demonstrate to you that I can write this as something negative and I can compensate for it by changing this ratio in there. So for our Arrhenius equation, we can write this also as x equals RT ln A over K. So I've put the minus that I had here, I put the minus in here and got to this. Now, a lot of people got stressed about this Arrhenius equation. And I will go into detail in the lecture then when we do the kinetics on that. Let's write it down. K equals A times, oh, for heaven's sake, e to the power of minus, and actually the x was the EA in the original Arrhenius equation, RT. So that is the original Arrhenius equation. No, you won't struggle. It is, don't worry about it. We will go through it. Is that the bit that you wanted to see? Okay, good. So that is the original Arrhenius equation. And what the Arrhenius equation actually wants to do is make a link between K and T. K in this case is the rate constant of a reaction, and we will discuss that in more detail, what this is, and T is the temperature at which a reaction happens. And that is the equation. How do we have to sort of think of that? How can we transform the whole thing? So let's do a transformation of this horrible equation, minus EA divided by RT. Let's transform that. And what we can do is we just take both sides ln. So we get ln K equals ln of A e to the power of minus EA over RT. And we are not worried about what EA and R actually represent or what the capital A is. We are not worried about that. We will get the concept later. I don't know whether this is for the phase 4 chemistry. Could very well be. I'm not sure. So, can we do anything with this part? Yes, we know because it's a multiplication here, A times e to the power of minus EA over RT. And we know that we can write this as ln A. Because it's a multiplication, it is plus ln E minus EA over RT. Right? I hope I haven't made a mistake. Now, what I see here quite nicely is ln and the E cancels out. Hey, how cool is that? So we have ln k equals ln A. And what have I got left? I've got minus EA over RT. Does that help me in any way? Does that help me in any way? Let me write this in a slightly different format. Let me write it as ln k equals negative EA over RT plus ln A. It's the same thing, isn't it? It's exactly the same thing. Does that help us? Tell you what, why don't we write it again, tweak it a little bit. We tweak it as ln k equals negative EA divided by R times 1 over T. That's this bit here. Yeah? Plus ln A. Does that make sense? And yes, we've got it. We've got the line for a straight, we've got the equation for a straight line, that way around. Y equals mx plus c. How does that look like? We've got a straight line. This point here, this is our y-intercept. That is C. That's this guy here. So that would be ln A. And what we plot obviously here is ln K. That's our y. This point is ln A. What do we plot on the x-axis? What do we plot on the x-axis? You're absolutely right. We plot 1 over t, because that is here our x. 1 over t. And what is the gradient for that? And I draw the gradient like this. What is the gradient? The gradient is simply minus EA over R, whatever these things are. So that is basically what this Arrhenius equation, this here, looks like when we linearize it, and that would be here the linear form of the Arrhenius equation. And that's all to it. It's not scary, it doesn't bite, hasn't got any teeth. I think the most complex thing about Arrhenius is the spelling of Arrhenius. Does it make sense to you guys? I think I just got a complaint from the housemates with whom we started it, those two here. They want to do something. So they want to do something, and I think I better oblige. So therefore, I am going to say goodbye to you, and thank you for watching. And I hope you enjoyed the session, and I shall see you soon for potentially another revision session. Happy with that? Thank you very much. Take care. Bye-bye.